In this illustration, we'll study about a sliding piston in a tube of different cross sections. Here we are given that a smooth vertical tube having two different sections is open from both the ends, but closed by two sliding pistons, as we can see here. And pistons are tied with an inextensible string, which we can see here. And is saying 1 mole of an ideal gas is enclosed between the pistons, and the difference in cross-sectional areas of piston is delta S. And the masses are M1 and M2. And is saying find the temperature by which the tube is raised so that piston will displace by a length L, and we can take the atmospheric pressure to be P0. Now in this situation here in solution we can see that when the pistons are in equilibrium here, and we can write for equilibrium of pistons, if T is the tension in a string and we consider Pg is the gas pressure, then here we can write down the equation for M1, and for M1 here we can write on this M1 due to atmosphere force acting on it in downward direction as P0 S1. If we consider S1 as the area of first piston, its weight is also in downward direction, which is M1G, plus string tension will also be acting on it in downward direction, and all downward forces are balanced by the gas pressure, which is Pg multiplied by S1. Say this first equation. And now we can write for M2. On this piston in downward direction, the force acting on it is Pg multiplied by S2 if we consider S2 is the area of this piston. Here we can also write S1 as area of M1, and S2 we can write as area of M2. So PgS2 is downward force on M2 as well as its weight, which is M2G in downward direction, and net upward force on it is T plus P0 S2. This is second equation. Now here if we add these two equations, then we can see 1 plus 2 will give us, if you add the two, tension get cancelled out, this P0 multiplied by S1 minus S2 plus M1 plus M2 multiplied by G is equals to Pg multiplied by S1 minus S2. And in problem we are already given that the difference in cross-sectional areas of the piston is delta S. So here we can simplify and write gas pressure is equals to P0 plus M1 plus M2 multiplied by G divided by delta S. Now we can use gas law for the gas, so we can write by gas law, as 1 mole of gas is taken, we can write PgV is equals to RT. We can write it as T1, which is the initial temperature, and if temperature is raised to T2, then we are given that the pistons are displaced by a distance L. So if the pistons are displaced in upward direction by length L, then the increase in volume of gas due to L length is delta S multiplied by L. So here we can write at temperature T2, which is greater than T1, which is increased. Here we can write Pg multiplied by the volume changes to V plus L delta S is equals to RT2. From these equations, if we just have a look over here, you can see if we subtract these two equations, then you can see we'll be getting Pg multiplied by delta S into L is equals to R multiplied by T2 minus T1. So we are required to find the temperature by which the tube is raised so that the piston will displace by a length L. So delta T we can calculate from here, which is T2 minus T1, that is equals to Pg multiplied by delta S L divided by R. So on substituting the value of Pg over here, this is L by R multiplied by Here the value of Pg gives us, initially you can write, when you substitute the value of Pg, this gives us P naught delta S plus M1 plus M2 multiplied by G. This is the result of this problem. The value of increment in temperature required for displacement of the piston by length L.